Dear students, today we will learn how current divides in parallel circuits. This is most important concept in analyzing real circuits in physics and engineering, and to check the branch current in electrical networks and to solve NEET, JEE and board exams faster. Let's see this concept. Whenever we have a parallel circuits like this, the current from the source does not flow entirely through any one of the resistor. Instead, it divides among all the resistors. How does it divide? That's where the current divider rule comes in. According to this rule, the current passing through this resistance R1, that is I1 is equals to total current times the opposite resistance divided by R sum of the resistances. In the same manner, we can take I2 is equals to total current times opposite resistance R1 divided by sum of the resistances. How can you get this? We know that from the Ohm's law, V equals to IR. Here resistors are connected in parallel, so let me consider RP. We know that for parallel resistors, parallel circuits, 1 by RP is equals to sum of the reciprocals of all the resistors. Here only we have two resistors, so that I can take 1 by RP equals to 1 by R1 plus 1 by R2. If I make RP as a subject formula, then I get R1 R2 divided by R1 plus R2. If I substitute this here, what happens here? See, V equals to I times R1 R2 divided by R1 plus R2. We know that from Ohm's law, I can take I1 is equals to V by R1. If I replace this V by this, what happens? You see, this is equals to I of R1 R2 divided by R1 plus R2, and here we have R1. And this R1 and R1 get cancelled. We left with I1 is equals to total current times opposite resistance divided by R1 plus R2. So this is how we will get this one. In the same manner, we can get I2 also. This is for two resistors. We can find directly I1 is equals to I times of total current times the opposite resistance divided by sum of the resistances. In the same way, I2 equals to total current times the opposite resistance divided by sum of the resistance. Now come to this circuit. If it is consisting 3 resistors or n number of resistors, what happens? So let us see. For 3 resistors connected in parallel, we can take I1 is equals to total current times 1 upon R1 divided by sum of the reciprocals of all the resistors, 1 by R2, 1 by R3. If you want to find out I1 like this. Same in the same manner, we can take I2 is equals to I times total current times 1 by R2 divided by R1 plus R2 plus R3. In the same manner, if you want to find out I3 is equals to total current times 1 upon R3 divided by sum of the reciprocals of all resistances. This is the current divider rule for 3 resistors or n number of resistors connected in parallel. If there are n number of resistances connected in parallel, then if you want to find out current through any one of the branch, let me consider IK, current through this branch. IK is equals to total current times 1 upon RK. If you want to find out the current through this resistance, let me take 1 divided by RK divided by sum of the reciprocals of all the resistances. So on 1 by R. This is what the current divider rule. Notice something interesting. Current through one resistor depends on the opposite resistor. That's why it's called a current divider. Let me solve some numerical examples to make this concept more clear. This is our first example. Here we need to find a current passing through this 6 ohm resistor. All these 3 resistors are connected in parallel, and we have total current passing through this combination is 12 ampere. So we can use current divider rule to solve this problem. So here the current passing through this 6 ohm resistor is equals to current is equals to total current times 1 upon the resistor, that is 6, divided by sum of the reciprocal of all the resistors, 1 upon 2 by 1 by 3 plus 1 by 6. On solving we get 12 amps times 1 upon 6, and here we get 2 amps. So in this way we can use current divider rule to find out current passing through individual resistor. Okay. Let's go to the next problem. In this example we need to find out ratio of currents passing through these two resistors which are connected in parallel. So we can use current divider rule to find the ratio of the currents. So here I1, let me mark this one as I1 and this is I2. We know that I1 is equals to total current into opposite resistance, that is 2R, divided by sum of the resistances R plus 2R, and this can be written as I of 2R by 3R, or else you can take 2I by 3. This is I1. Next I2 can be written as total current passing through the combination and opposite resistance is R divided by sum of the resistance 2R. This is equals to I of R by 3R, and this is equals to I by 3. Now we need to find out I1 by I2. I1 by I2 is equals to 2I by 3 is to 3 by I. So we get 2 is to 1, 2 by 1. So the answer is 2 is to 1. Let's go to the next problem. In this example we need to find out current through the branch CD. So we can use current divider rule to find out this one, and Kirchhoff's junction rule also. To apply current divider rule we need total current. So first let me find out total current. To find out total current we need total resistance across this combination, that is resistance AB, that is RAB. The resistance across AB equals to, that is these two resistances are connected in parallel and these two also connected in parallel, and these two combinations are connected in series. So that whenever these two are connected in parallel we can use this formula, that is R1 R2 divided by R1 plus R2. So let me consider this R1 and this is R2. So 1 into 3 divided by 1 plus 3, plus, because these two are connected in series, no, so we can use plus, and here R1 is 2 and R2 is 4. So R1 R2 divided by R1 plus R2, 2 plus 4, and this is equals to 3 by 4 plus 8 by 6, and this is equals to, so LCM is 12, and here so 9 plus 16, and here this is 25 by 12. This is total resistance across AB, and we need current, total current. Current is equals to voltage divided by resistance from Ohm's law, and here the voltage across this combination is 50 volt divided by this total resistance is 25 by 12. So on simplifying we will get 24 amps. 24 amps is the total current. Now the current passing through this 1 ohm resistor, let me take this one as I1. Current passing through the 1 ohm resistor is I1. I1 is equals to total current, that is total current is 24 amps into opposite resistance is 3 ohm divided by total resistance 1 plus 3 according to current divider rule. This can be written as 24 into 3 by 4, and this is equals to, so 18 amps. In the same way, I2 is equals to, let me consider the current passing through this 2 ohm resistor is I2. This I2 can be written as total current as per the current divider rule. Total current is 24, total current opposite resistance is 4 ohm, divided by total 2 plus total resistance is 2 plus 4, and this is equals to 24 times 4 by 6. So, this is equals to 16 amps. Now, look at this junction. The current entering the junction is 18 amps, that is I1 current passing through this 1 ohm is 18 amps, and current passing through this 2 ohm resistance is 16 amps. So, according to Kirchhoff's junction rule, the total current entering the junction is equals to total current leaving the junction. Let me consider this current is I. So, this is equals to 18 amps as per the current rule, that is Kirchhoff's current rule. We can take total current entering the junction is equals to total current leaving, 16 amps plus I. This I is equals to now 2 amps. So, in this way we can solve easily by using current divider rule. If you found this video is helpful, don't forget to like this video. In the next video, we will explore voltage divider rule, which is the twin brother of this concept. Stay tuned. Thank you.